starting the differentiation worksheet. Question number 1. The equation of a curve is y equals 2 cos x plus sine 2x. Find the x coordinate of the stationary point on the curve for which x is between 0 and pi, and determine the nature of each of the stationary points. All right. So we know that at a stationary point, the derivative or the gradient is basically 0. That means dy over dx is 0. So let's derivate this. Y equals 2 cos x plus sine 2x. Derivate this, we would get dy over dx. 2 is just the coefficient, so it stays 2. Derivative of cos x is minus sine x plus derivative of sine 2x would be cos 2x times 2. And then we equate it to 0. So we're getting minus 2 sine x plus 2 cos 2x equals to 0. We have to solve this and get the values of x. So we can use the double angle formula for cos 2x. It's already there in the formula sheet. Cos 2x is equals to 2 cos square x minus 1, or 1 minus 2 sine square x, or cos square x minus sine square x. So I'm going to use this one. So I get an equation in terms of sine x only. So this would be minus 2 sine x plus 2 cos 2x would be 1 minus 2 sine square x equals 0. So minus 2 sine x plus 2 minus 4 sine square x equals to 0. Minus 2 sine x plus 2 minus 4 sine square x equals to 0. Rearrange 4 sine square x plus 2 sine x minus 2 is equals to 0. I'm also dividing with 2. So we get 2 sine square x plus sine x minus 1 is equals to 0. This is a hidden quadratic equation. Solve it using middle term breaking. So you get sine x equals half. You have to use quadratic formula or middle term breaking. I've directly found this using the calculator. But if I don't show an intermediate step, I will lose method mark. And when you lose method mark, you don't get any accuracy mark after that. So if you don't show this step in between, you won't get any mark after this step. So I'm going to take 2 to the other side. 2 sine x minus 1 is the first bracket, and sine x plus 1 is the second bracket equals to 0. Better to just do the actual middle term breaking. All right, so we're getting sine x equals minus 1 and sine x equals half. Solve this between, and the answer should be between 0 to pi. So when sine x is equals to half, we need the answer in the first and the second quadrant. So what's going to be the answers? X equals sine inverse, make sure you're in radians. So sine inverse 0.5 is pi by 6. Sine is positive in the first quadrant and the second quadrant. So the second answer would be pi minus pi by 6. That's going to be 5 pi by 6. So For half, we're getting two solutions in the first and second quadrant, pi by 6 and 5 pi by 6. And the second quadrant, the value of x is sine x equals -1, second value of sine x. Sine is negative in the second and third quadrant. So this will give solution in the third quadrant and in the fourth quadrant, which is not in the given domain. So just write out of domain. No need to even solve it because we know we'll get answers bigger than 180 degrees and less than 360 degrees, or bigger than pi and less than 2 pi. So that's out of our domain. The only answers are pi by 6 and 5 pi by 6 for question number 1. Okay, question number 2. हैदर, जो आपने मुझसे क्वेश्चन भेजा था वो हुआ?
नहीं मैम।
अच्छा, मैं क्लास, मेरी इसके बाद एक और क्लास है, मैं इसके बाद करके भेजूंगी। ठीक है, मुश्किल है, देख के तो आसान सा लग रहा है आइडेंटिटी का क्वेश्चन।
मैम मेरे से सॉल्व नहीं हो रहा था उसमें, मेरा
चलो मैं करके
10
देखती
का
हूँ।
आंसर आना था, इवन तो कुछ और आंसर होना चाहिए था उसकी जगह।
अच्छा चलो मैं देखूंगी, मे बी बीच में थोड़ा ट्रिकी हो। Alright. Question number 2. The curve y is equals to e power x plus 4 power e power minus 2x has one stationary point. So stationary point means dy over dx has to be equated to 0. Find the coordinates of this point. So let's derivate y equals e power x plus 4 e minus 2x. So dy over dx is going to be, derivative of ex is just ex plus the coefficient is 4, so that's 4. And the derivative of e minus 2x, we know that the derivative of e power fx is, we're derivating it, it's e fx, it stays the same, times f prime x, times the derivative of the power. It's going to be e minus 2x times minus 2. So dy over dx is e power x minus 8 e power minus 2x, and we must equate it to 0. Okay. Okay, now we solve it for the value of x, find the x coordinate of the point. Okay, so we have e power x is equals to 8 e power minus 2x. Okay, I'm sending e power minus 2x to the other side, it gets divided. When powers are being divided, they get subtracted. AM upon AN equals AM minus N. It's going to be e power x minus minus 2x. So that's e power 3x equals to 8. Again, we have to find the value of x. So remember from log, what should be the next step?
e power x is equals to 2.
Sorry?
मैम 3 कैंसिल आउट कर देंगे दोनों साइड्स में, तो फिर e पावर x इज इक्वल्स टू 2, उसके बाद
3
लॉग्स।
3 कैसे कैंसिल हो रहा है?
मैम क्योंकि पावर 3 लगा हुआ है e के साथ, और 8 को अगर अंडर क्यूब रूट करेंगे तो फिर 2 निकल आता है।
अच्छा ठीक है, आप दोनों साइड पे क्यूब रूट कर रहे हो। ठीक है, आप कह रहे हो कि e पावर 3x equals to 2 cube. अच्छा ये कह रहे हो, and then you're going to take cube root on both sides. So cube root is power 1 by 3 on both sides. Okay, and then this and this cancels, and this cancels. So ex equals to 2, and then what?
लॉगरिथम्स।
ठीक है, so take natural log on both sides, ln on both sides. So it's going to be x ln e equals ln 2. So ln e is 1, so x equals ln 2. ठीक है, let me check that. Yes, x equals ln2.
मैम अगर ये इस फॉर्म में लिखते तो फिर उसको मार्क कर देगा करेक्ट, अगर सिर्फ इसी मतलब कि LN2 के फॉर्म में लिखे और उसको
Yeah,
सिंप्लीफाई और ना।
LN2 is fine. LN2 is absolutely fine. Unless question had said, give your answer correct to 4 decimal place. Give your answer correct to 4 significant figure. फिर LN2 नहीं लिख सकते. When the question is not giving you a clear picture whether it wants an answer in exact form or rounded off form, then it's totally up to you. Okay. So X comes out to
ठीक है
be
मैम।
LN2. I might, I had something else in mind. I was going to send e to the other side directly. So we get 3x equals, when e goes to the other side, it becomes ln 8. Then ln 8 can be written as ln 2q, which can be written as 3 ln 2. So we get 3 ln 2 and 3x, and then 3 and 3 cancels, and x equals ln. But I like this more. Achha, so we got x, which is ln2. Determine the nature of this point. So yeah, we have to determine the nature of stationary points. That means you have to tell whether this is a maximum point or a minimum point. So what do you have to do? You double derivative and you substitute the value of x in that double derivative if needed. And then you check if your answer is positive, then it's a minimum. And if it's a negative answer, then it's a maximum. All right. So where's my first derivative? First derivative was this. Let's derivate it again. So for part 2, dy over dx is e power x minus 8 e power minus 2x. So the second derivative is going to be e power x derivative is still e power x. Minus 8 is the coefficient. E power minus 2x derivative is e power minus 2x. However, you have to multiply the derivative of the power, which is minus 2. So e power x minus 16 e power minus 2x. That's the second derivative. You have to substitute x equals ln 2. When you do that, you have to tell me whether you get a positive answer or a negative answer. E power ln 6 आता है.
मैम एग्जैक्ट वैल्यू।
Okay, सही है. They give 6. Let me check. Yes. So 6 is greater than 0. So minimum. Question 3. Okay, that's an implicit equation. हैदर आपने किया मेरे साथ implicit equation. मुझे लगता है आप भी नहीं आ रहे थे इन दिनों से 8 की वजह से.
हमें एक दिन आया तो उसमें मैंने कर लिया था इम्प्लिसिट इक्वेशन।
चलो ठीक है. अच्छा, अब हमने क्या करना है? फाइंड द ग्रेडियंट ऑफ द कर्व विद दिस इक्वेशन 2x स्क्वायर माइनस 4xy प्लस 3y स्क्वायर इक्वल्स टू 3. अब ये इम्प्लिसिट इक्वेशन है. इम्प्लिसिट इक्वेशन क्या होती है? जिसमें आप y को सब्जेक्ट नहीं बना सकते. अगर y सब्जेक्ट बन जाता तो हम आराम से कर लेते हैं dy over dx. But since it has a y term as well as a y square term, we cannot make that subject. So now what you have to do, you have to derivate this with respect to x. Let's start doing that. 2x square का तो हमें derivative पता है. क्या होता है? 4x. So I'm going to write 4x. First write derivative with respect to x. Okay. So the derivative of 2x square would be 4x. अब इसके साथ ना Fazil, there's also a dx over dx, which we never write because it cancels and gives us a 1. But whenever you're actually derivative 2x square, you write 4x and then you derivate x again. This has to be derivated again, which is just 1. So we don't generally show it. In fact, we never show it. And then there's minus 4. And now it's xy. How do we derivate xy? We use the product rule. So the product rule would be derivate x, which is 1, or you may also write dx over dx. All right, and then just multiply the second function, which is y, with it, plus sign, multiply the first function x, and now derivate y. We're derivating it with respect to x. So it's going to be dy over dx, bracket close, plus 3. And now we have to derivate y square with respect to x. So that's going to be 2y, but we're not done because we're derivating with respect to x. It's going to be dy over dx with that. Equals to derivative of 3 is 0. So we're getting 4x minus 4y minus 4x dy over dx plus 6y dy over dx equals 0. So let's take dy over dx common and send everything else to the other side. Okay, let's keep 4x minus 4y here and send the dx dy terms to the right and also take dy over dx common. So we get 4x minus 6y divided. So we have 4x minus 4y upon 4x minus 6y, which is dy over dx. So to find the gradient, you need a value of x as well as a value of y, which is 2, 1. Substitute 2, 1 in this equation of the expression for the gradient and tell me what the gradient comes out to be. What do we get for dy over dx?
2.
2 is correct. समझ आइए फसी?
जी मिस।
Question 4 देख. The diagram shows the curve y equals ln x over x square and its maximum point M. The curve cuts the x-axis at A, write down the x coordinate of it. All right. So the curve cuts the x-axis at A. So when a curve cuts x-axis, what do we know about that point?
y equals 0.
Y is the 0. So x is some x and y is 0. All right, so substitute y equals 0 in the curve. 0 equals ln x over x square. So 0 equals ln x. Send ln x to the other side. When you send ln x to the other side, it becomes e. So e power 0 equals x. X equals 1. So the x coordinates of A are x equals 1. Yes, that's correct. So we have 1 here. Okay. Find the exact coordinates of M. So M is the maximum value, which means dy over dx is going to be 0. We have to derivate this ln x over x square. So that is the product rule, fx over gx. How do we derivate this? f prime x times gx minus sine fx times g prime x upon gx whole square. That's the quotient rule of differentiation. So let's derivate it. Ln x derivative is 1 upon x times x square minus sine. Ln x stays the same. Derivative of x square will be 2x upon x power 4 equals to 0. So x square gets eliminated, x power 4 gets eliminated, and we're left with x minus 2x ln x equals to 0. Let's take x common. So x minus 2 ln x equals 0. So one of the values of x is coming out to be x equals 0, which can't be correct. Sorry, that's 1, not x. Okay. So no way that x is 0 at end. Looking at the figure. X 0 to nahi ho sakta. Moving on to the other answer, which is 1 equals to ln x half equals ln x. Send x to ln to the other side, we get e power half equals x. Yeah. So the answer written is square root of e equals x. Find the exact coordinates of m. So you need x comma y as well. Now to find y, substitute x equals under root e in the given equation for y. So y equals ln e power half upon e power half square. So we have an e in the denominator, and the numerator becomes half ln e, and ln e is 1. So we have half upon e, 1 by 2 divided by e, which is just half e. Balki 1 over 2e. It's 1 over 2e. So the coordinates of m are e power half, comma 1 by 2e. Let me confirm. Yes, that's correct. Square root of e, comma 1 by 2. Part 3 requires integration, which I have not taught yet. So we'll do that again with the in the integration worksheet. Question 5. Just a second, I need to open a new board while I hand over. Okay, question number 5. The diagram shows part of a curve y equals x upon x square plus 1 and its maximum point m. The shaded region R is bounded by the curve and by the lines y is equals to 0 and x equals p. Calculate the x coordinate of m. Okay. For x coordinate of m, derivate the curve, equate it to 0 because m is the maximum point. To derivate the curve, we have to use the product rule, which is derivative of x is 1 times the denominator gets multiplied, negative sign, The numerator gets multiplied. Denominator's derivative is 2x plus 0, so just 2x, upon square of the denominator, which is x square plus 1 whole square, equated to 0. The denominator just gets eliminated, so we have x square plus 1 minus 2x square equals 0. So I'm getting 1 equals x square. So I'm getting x equals plus minus 1. Looking at the figure, the m has a positive x coordinate. So the answer would be x is equals to 1. Part 2 and part 3 will do with the integration section. So only one has to be done. Question number 6. The perimetric equation of a curve Rx equals 2 theta plus sine 2 theta and y equals 1 minus cos. Perimetric equation तो होती है जिसमें एक थर्ड वेरिएबल आ जाता है. इसमें एक तो x है, एक y है और अब एक थीटा भी है. तो जो x होता है ना, वो भी किसी एक थर्ड वेरिएबल पे डिपेंडेंट होता है और y होता है वो भी किसी थर्ड वेरिएबल पे डिपेंडेंट होता है. Show that dy over dx is tan theta. Alright, let's derivate x in with respect to theta, then y with respect to theta, and then we'll use chain rule. So dx over d theta is going to be derivative of 2 theta is just 2 plus derivative of sine 2 theta would be 2 cos 2 theta. Then the derivative of dy over d theta is going to be derivative of 1 is 0 minus derivative of cos 2 theta is going to be minus sine 2 theta times 2. So we have 2 sine 2 theta. Okay. So chain rule, we have to find dy over dx. So that's going to be dy over d theta times d theta over dx. So dy over d theta is 2 sine 2 theta and d theta over dx is going to be the reciprocal of 2 plus 2 cos 2 theta. Going to take 2 common from the denominator, cancel it with the 2 in the numerator. So we get sine 2 theta over 1 plus cos 2 theta. Now this must be equals to tan theta. ये हमने proof करना है. So how do we do that? It's just tan theta, not tan 2 theta. That means we have to write the double angles as open the double angle formula. So sine 2 theta is 2 sine theta cos theta. And then 1 plus cos 2 theta would be, let's use 1 minus 2 sine square theta. That's going to give us the numerator is still 2 sine theta over cos theta. Then we have 2 minus 2 sine square theta. So I'm going to take 2 common from the denominator. One minus sine square theta. Cancel the 2 and 2. 1 minus sine square theta is what? Cos square theta. So sine theta, cos theta upon cos square theta. So the square and the cos theta gets cancelled. We have sine theta by cos theta which is tan theta. Oh, question 7. The equation of a curve is xy bracket x plus y equals 2a cubed, where a is a non-zero constant. Show that there's only one point on the curve at which the tangent is parallel to the x-axis and find the coordinates of this point. Show that there's only one point on the curve at which the tangent is parallel to the x-axis. So let me just draw a random curve like this. The tangent is parallel to the x-axis. So when the tangent is parallel to the x-axis, so the gradient or dy over dx is equals to 0. Okay, let's find dy over dx for the given equation. We're going to expand it. It's going to be x squared y plus xy squared equals 2a cubed. X square y plus xy square equals to a cube. Right now, let's find dy over dx for this. So it's an implicit equation. Derivative of x square y. You have to use product rule. So 2x times y plus x square dy over dx plus the derivative of xy square. So 1 times y square plus x times 2y and then dy over dx and equated to 2a cube's derivative is going to be 0. So equals to 0. So we get 2xy plus x square dy over dx plus y square plus 2xy dy over dx equals to 0. So take the non-dy over dx terms to the other side, minus 2xy minus y square, and take dy over dx common. We get x square plus 2xy. Now, send the denominator to the other side. Dy over dx equals minus 2xy minus y square upon x square plus 2xy. Says that the tangent is parallel to the x-axis, that means the gradient is 0. So whatever expression we got for dy over dx equated to 0. So let's equate it to 0. So that means the numerator is equals to 0. So minus 2xy minus y square equals to 0. Take y common. Minus 2x minus y equals to 0. So we're getting y equals to 0 and y equals minus 2x. Let me confirm. Okay, so what we were showing, show that there is one point of the curve at which tangent is parallel to the to the x-axis. So far, we're getting 2 points. We got 2 y's. Let's put it in the original equation and try to get 2x. So when y is 0, what happens to the original equation? since y is being multiplied with everything, it becomes 0. But 0 is not equals to 2a cube. 2a cube is a constant. So it can't be equals to 0 because it says a is a non-zero constant. So not possible. So at y is equals to 0, you're getting 0 is equals to 2a cube instead of a value for x. That means it's not possible. Okay. Let's solve the same for y is equals to minus 2x. So x instead of y, write minus 2x. Then x plus, instead of plus y, write minus 2x equals 2a cube. So we're getting minus 2x squared times minus x, which is 2x cube, equals 2a cube, meaning x equals a. So the coordinates are, so x is equals to a, meaning y equals minus 2a. So the coordinates are a comma minus 2a, where the tangent is parallel to the axis. That's correct. Find the coordinates of this point. So we're done with question number 7. Okay, so you're going to take the next 2 questions as homework, question 8 and question 9. I'll see you tomorrow, inshallah. If you have any questions, please ask. Redo this question as well. This was tricky.
Allah Hafiz, ma'am.
That's it.